Hello friends, welcome to my channel. We have given a problem of complex number which has been asked in JEE Main 2023. We are going to solve this. So first of all we are going to use here triangle inequality. So we have given that z is a non-zero complex number and mod of z minus 1 upon z equals to 2. Then we have to find out the maximum value of mod z. So modulus of z. So again, first of all we can write mod of z equals to mod of z minus 1 upon z plus 1 upon z. So, and using triangle inequality, take z minus 1 upon z as a first complex number, and 1 upon z as a second complex number. So we can write it as mod of z minus 1 upon z plus mod of 1 upon z. So this can be written as mod of z is less than or equals to the value of z minus 1 upon z is 2, and this is 1 upon mod z. Why? Since z1 upon z2 mod of z1 upon z2 equals to mod of z1 upon mod of z2. So this quantity can be this equation, since mod of z is non-zero, therefore mod of z is also non-zero, and mod of z is always greater than equal to 0, but mod z is not equal to 0, so mod of z is strictly greater than 0. So if we so this can be written as, if we take so if we take if if we take if we take mod z equals to y, then this inequality can be written as y is less than or equals to 2 plus 1 upon y, and this is, so this can be written as, this quadratic inequality can be written as, this inequality can be written becomes y square less than 2y plus 1, and this equals to y square minus 2y minus 1 is less than or equals to 0. So this quadratic inequality, so first of all, to solve this quadratic inequality, we are going to find out the roots of this quadratic equation. So first of all we are going to find out the roots of the quadratic equation using quadratic formula. We know that ax square plus bx equals to plus c has roots are x equals to minus b plus minus b square minus 4ac upon 2a. So using this formula we are going to find out the roots of the given quadratic. So roots are minus of 2 plus minus b square minus 2a square minus 4 into minus 1 into 1 upon 2 into 1. So this becomes, again using this can be written as 2 plus minus, this is 4 and this is plus 4 upon 2, and this can be written as 2 plus minus square root 8 upon 2, and this can be written as 2 plus minus 2 root 2 upon 2, and this is equals to y equals to 1 plus square root 2, and this again y minus square root 2. So we have two roots. One is 1 plus root 2 and another is 1 minus root 2. So we are going to find the interval in which this quadratic inequality is valid. So first of all, draw a number line. Since this is number line, again this lies first, so 1 minus root 2, and this is 1 plus root 2. So we know that in this interval the quadratic inequality is plus, this is minus, and this is plus. So in this interval minus infinity to 1 minus 2, quadratic inequality is positive, and 1 plus root 2 to infinity, this is positive, and this in this interval 1 minus root 2 to 1 plus root 2, this is valid. So valid solution is y less than or equal to 1 plus root 2. So again this is a negative quantity, so we are going to remove here equality sign. We are taking here a strict inequality, so this becomes 1 minus root 2 again, and what is y mod of z is less than or equals to 1 plus root 2. So we are looking here that mod of z is less than or equals to 1 plus root 2. So maximum value of z is z maximum always less than or equal to 1 plus root 2. So less than or equal to, so maximum value of mod z equals to 1 plus root 2. This is the required answer. But we are going to discuss about that why lies between this solution. Since if you are putting any number greater than 1 plus root 2, the above inequality, so the above inequality is positive. So this is positive in this interval, this is positive. And if we are putting such that 0 y equals to 0, then this is negative. So negative, and so therefore in this interval we are putting negative sign. And if we put any number less than 1 minus root 2, the quadratic inequality becomes positive. And we are looking here that we have to find only those solution of y for which this quadratic inequality becomes negative. So in this interval 1 minus root 2 to 1 plus root 2, quadratic inequality is negative. So this is the valid solution. This is the valid solution of valid interval of y. So the maximum value of, given given inequality is 1 plus root 2. So we have solved our problem. Thank you.